Welcome back to Mathematical Literacy. Today we're going to be talking about the fixer-upper. Before we can talk about fixing up a house, we need to talk about how we measure things and how we measure areas. If we're talking about rectangles, we can have rectangles of various sizes, even squares. All rectangles have a length and a width, and opposite sides of a rectangle have the same measurements, whether we label that length or width. And it doesn't particularly matter which one we consider the length and which one we consider the width, as long as we are consistent that opposite sides have the same measurement. And the other thing that's true about all rectangles is that all four angles of the rectangle are right angles. Let's ignore the angles for a little while, and let's talk about the two variables that we have when we're talking about rectangles, and that is the length and the width. So we'll let L stand for length, as I've obviously already done, and W stand for width. So then we can talk about the area of a rectangle. The area will equal the length times the width. If we substitute some measurements for some of these lengths and widths, we can calculate the areas of these triangles. Let's start with a width of 3 inches, a length of 8 inches on this rectangle. So the area would be equal to 3 inches times 8 inches. So when we do that multiplication, we get 24, but we no longer just have linear inches. We actually have inches squared. Let's look a little more closely at what that means. Now, if we were just to multiply 3 inches by 8 inches and not square the inches, then we would just have 24 inches, and we would be measuring out this way, and it would go way, way out that way. But we are actually measuring an area. So if we mark off 3 inches on one side and 8 inches on the other, we actually have square inches in here. Each of these is a square, and if you count them, we have 24 square inches. Each of these is 1 inch on the side, each side. But we can work with other types of shapes. For example, we have the parallelogram. A parallelogram is similar to a rectangle in that opposite sides are equal. They have equal lengths. In fact, why don't we call this one the length? However, this side is not the width of the parallelogram. The width is actually here. So we usually don't use the terms length and width when we're dealing with parallelograms. Instead, we talk about base and height. Why does this work? Well, let's think about this height, which is the same for a parallelogram. And that kind of marks off a triangle here at the end of the parallelogram. Well, if we move that triangle to the other side, remember we called this the height. If we have cut that off from this side so that this side is no longer there, then we actually have a rectangle, length times width, except we have used the symbols base and height to indicate the length and width. So with the parallelogram, we will use the formula area equals base times height. So this parallelogram actually has the same base and height measurements as the rectangle did. Therefore, the area of this parallelogram equals 3 inches times, another way of writing times, 8 inches, or 24 square inches, or inches squared. And there's a square inch. And remember, the variables we are interested in when we are calculating the area of a parallelogram are the base and the height. Let's look at a triangle. By drawing the triangle on a grid, if we let every 2 dots equal 1 foot, it's really easy to see that the bottom side of this triangle is 6 feet long. The other sides are harder to guess at what they might be because they don't line up exactly with the grid. But triangles are very interesting. See what happens if we rotate this one around and then we move it. We slide it over, and my triangle sides aren't exactly straight, but if they were, those two sides would line up exactly. Now let's look at what we have. Oh, it's a parallelogram. And the height of this parallelogram is right here. And it's 4.5 feet. So 4.5 feet. Okay, the area of this parallelogram would be the base times the height. But we did not start with that. We started with just half of this. So that's why the formula for the area of a triangle is 1/2 the base times the height, where b equals the base and h equals the height. So in this case, what we're dealing with is an area that is equal to 1/2 the base of 6 feet times the height of 4.5 feet, or 4.5 feet, which equals 13.5, but we're doing feet times feet. We have an area, so the units are square feet. And finally, let's look at a trapezoid. A trapezoid has two different lengths going across this way. In fact, with a trapezoid, we usually call that base 1 and base 2. But we can still talk about a height, and we can still think about manipulating this triangle. When we do that, we once again have really gotten rid of this part of it. But take a look at what that has actually done to the original bases. The original base, B1, was here. The original base, B2, was here. And we actually have now a base, what color shall I do it in now, that is larger than B1 and smaller than B2. In fact, it is the average of them. So if we add B1 plus B2 divided by 2, taking the average, we get the value that we actually use in our formula for the area of a trapezoid. So the area is going to equal 1/2, which is another way to write this, 1/2 times base 1 plus base 2. But to get the area, we still have to multiply by the height. So 1/2 of base 1 here plus base 2 here equals the height. Or in the colors that I've chosen for it there, it would be, let's use this, 1/2 times base 1 plus base 2 times the height. So for these given measurements, the area would equal 1/2 of the base 1, which is 8 meters, plus base 2, which is 4 meters, times the height of 4 meters, or 1/2 times 12 meters times 4 meters, or 24 meters squared. Now 24 square units has showed up often in this video. It's just happening because I'm using simple numbers. If I gave you more complicated numbers like perhaps 4.36 is one base and 5.73 whatever, you're not always going to wind up with something around 24 meters squared. Let's move on to one last shape. Let's take a look at a circle. And to use slightly different numbers, make it a little more interesting, let's make it have a radius, which is what R stands for, of 5.3 centimeters. And so R stands for radius of 5.3 centimeters. The area of a circle equals pi, which is a very special number. It's an irrational number. Pi is exactly what it is. We approximate pi in different ways. We can approximate it as 22 over 7. We can approximate it as 3.1415. And if you do that, it actually goes on forever. At some point, we have to round it, which makes it an approximate number. But pi doesn't have any units. It's just a ratio. What we need when we're talking about area, we have to have square units, not just a length. So what we're going to do is we are going to square that radius. So for this given circle here, pi r squared, pi times 5.3 squared. You have a button on your calculator, and that button times 5.3 squared should give you 88.2 centimeters squared. Because remember, when we squared 5.3, we were actually squaring 5.3 centimeters to give us these square centimeters. Also remember that the diameter equals 2 times the radius. Sometimes you may be given the measure of the diameter instead of the radius. Also, you might need to remember that the circumference, or the distance around the circle at the outside, is equal to 2 pi r. Notice going around, we are measuring a length. The radius is not squared. When you're talking about the circumference, it's 2 pi r. Before we move on to volume, I'd like to say a word about a special rectangle, the square. For a square, the length and the width are the same, so we often use the letter S to indicate the length of the sides. And since all the sides are the same, they all have the length S. So the area of a square equals a side times a side, which is the same thing as a side squared. Do you see where the name comes from? Okay, side times side. Side raised to the second power is a side squared. So if you were given something like 25 miles, square miles even, the area of a plot of land is 25 square miles, what is the length? And it is a plot of land that is the shape of a square. What is the length of one side of the plot, or the field of one, or the piece of property? What's the length of one side? Well, if they are the same, what we have is s squared equals 25. Therefore, we're going to take the square root of both sides. Okay, the square root of 25 is either positive 5, because 5 times 5 is 25, or it's negative 5, because negative 5 times negative 5 gives you positive 25. However, you have to think about what's going on in the real world with areas, and you cannot have a negative area. You have less than nothing. Okay, so we only deal with the positives when you're talking with about area. So a side on this case equals 5 miles. Each of the sides of this square plot of land is equal to 5 miles. Okay, and just a quick check, 5 times 5 is 25 miles squared. That works. Length of one side is 5 miles. So when we talk about volume, we have to add another dimension, the third dimension. We have length, we have width, and then we have height. So if we are talking about these measurements, say 15.3 inches in length and a width of 12.7 inches and a height of 32.5 inches. Okay, if those were our measurements, length, width, and height, 15.3, 12.7, and 32.5, When you're measuring, you need to have some type of unit. Okay, so if those are length, width, and height, how do we calculate volume? We multiply the three of them. So in this case, we would get, okay, watch what happens when we write it out. There's times inches, times inches, times inches. So we're going to get something inches cubed, or cubic inches. So that's equal to about 6,315 cubic inches. If you must know, on the calculator it actually said 6,315 and 75 thousandths of an inch, of a cubic inch. Okay, but we're just rounding it to the whole number. So this is really like taking the area of the base, which in this case is a rectangle, and then just moving it upward for the height. So you could do area times height. Now actually, you can take any of the shapes that we've been working with, say the circle, and if we tilt it and we duplicate that so we have two ends, we can connect those two and we now have a cylinder, and the volume of that cylinder would be equal to the area of the base times the height. So the volume of this cylinder, and here's something you can do. You can indicate which volume it is by putting a little subscript there just to tell everybody the volume of this cylinder is equal to the base, which was a circle, so the area of the base is pi r squared times the height. For instance, if we have a radius here equal to 7 meters, then we would have a volume of pi times 7 squared times, and we'll say the height here is 15 meters. Okay, so that's the height. You can put that right into your calculator using the pi button and get 2,309 meters cubed. Now notice we have meters squared within our formula, m squared, times another meter, so we have meters cubed, or meters to the third power. Volume should always be expressed with a cubed unit, or a unit to the third power. And you can turn any of these areas that we've been working with, if you use one of those triangles or trapezoids as a base and just extend it in a third dimension, you will get a volume. We will be combining geometry and dimensional analysis as we work through some home improvements in this next section.